In this set of videos, I'm going to discuss the basic integration free response problem set that we've been working on. In this first problem, we have that 5x cubed plus 40 is equal to the integral from c to x of f of t dt. Well, when you see something like the integral from c to x of f of t dt, you see an integral defined function. You want to think of the fundamental theorem of calculus, which says that the derivative of this integral defined function from c to x of f of t dt, where t is going to be a dummy variable there, is just equal to f of x. And I won't go into that. That is the fundamental theorem of calculus part 1 or part 2, depending on what book you use. And I like to think of it as part 1 because it is necessary to prove part 2. However, the one that is most useful is the second part of this. So when I see that, I want to think of derivatives here. So what I'm going to wind up doing is taking the derivative of both sides. So I'll have the derivative of 5x cubed plus 40 is equal to the derivative of the integral from c to x of f of t dt. And the left side of that is just 15x squared, and the right side is f of x, and so that gives me part 1, find f of x. Now in part 2, we're trying to find the value of c. Well, now that I know f of x is equal to 15x squared, I can rewrite the given function 5x cubed plus 40 is equal to the integral from c to x of 15t squared dt, and using t as a dummy variable. Again, as long as I have the integral defined function with x as my independent variable, then I need to rewrite the integrand in terms of a dummy variable, in this case t. So this time I'm just going to work out the right side. The left side I'm going to leave alone. And I can take the antiderivative of 15t squared. That's going to be 15t to the third over 3, or 5t cubed. And that's from c to x. And so we evaluate the antiderivative at the upper limit. We'll get 5x cubed minus the antiderivative evaluated at the lower limit. So that'll be 5c cubed. And now we know that that has to equal 5x cubed plus 40. At which point we can cancel out the 5x cubes or subtract 5x cubed from both sides. And we end up with 40 is equal to negative 5c cubed. Divide both sides by negative 5, so that c cubed is negative 8. And finally c is equal to negative 2. And so that's our answer for part 2 of A. Okay, now we're ready to look at part B. If capital F of x is equal to the integral from x to 3 of square root of 1 plus t to the 16th dt, find f prime of x. Again, this is bringing us back to the fundamental theorem of calculus, part 1, with a slight twist. This time, because our limit of integration is in the bottom, we're going to need to flip that and take the opposite sign. So if f of x is the integral from x to 3 of the square root of t to the 1 plus t to the 16th dt, then that's equal to the negative of the integral from 3 to x of the integral of square root of 1 plus t to the 16th dt. So at this point we can find the derivative, and remember the integral of f of capital F of x, which is f prime of x, is just equal to little f of x. So we're just going to plug x into the integral expression, and that's just negative square root of 1 plus x to the 16th power. And that's all we have to do for that. And again, that's the reason for that is this is how we define the derivative of an integral defined function. Going back to our very first statement, the derivative of the integral from c to x of f of t dt is just f of x. So the integral of negative, or the derivative of the negative of the integral from 3 to x of square root of 1 plus t to the 16th dt is just negative square root of 1 plus x to the 16th. Done. And so this problem is really an exercise in the fundamental theorem of calculus. Both parts are involved in this, with a heavy emphasis on that first part there. Alright, so we'll go on to the next problem now.